When you ask an AI to rewrite a backend by analyzing a 50-file codebase, it has to navigate a massive digital labyrinth. Standard large language models approach this task sequentially. They plan, read, and write within a single linear thread of logic. At an enterprise scale, this creates a latency bottleneck. Executing complex tasks one step at a time can take hours, stalling human momentum while the model grinds through the data. Scaling also introduces context rot. This is a silent degradation of quality that occurs as the model's active memory becomes crowded with competing files and instructions. As the model processes dozens of files, the density of information degrades quality. It hallucinates code or contradicts earlier analysis as memory reaches limit. Expanding the context window doesn't fix the chaos, it just creates more noise. To handle complex autonomous tasks, the architecture must change. The AI cannot function as a single smart encyclopedia. It has to become a decentralized orchestrator. In this new architecture, a lead agent acts as the central node, receiving a complex prompt from the user. Rather than attempting the work immediately, the lead agent acts as a project manager, analyzing the requirements to build a step-by-step project plan. Modern models now proactively recognize when a task is too heavy for a single thread, choosing to delegate the workload without any explicit human instruction. The system deploys sub-agents for specific goals, one to research the codebase, one to write the logic, and one as a QA tester. These sub-agents execute their tasks simultaneously. They don't wait for one another, allowing for massive parallel processing. This parallel execution compresses the timeline. What was once hours of serial processing is reduced to minutes, solving the latency bottleneck. Speed is the first major gain here. However, to ensure the output remains precise, the system must also solve the memory problem. We can see the precision of this system by looking at how a single sub-agent handles its piece of the task. Accuracy at this scale is maintained through a process called context isolation. These sub-agents are spawned in an isolated sandbox. They do not share the massive, bloated conversation history of the main lead agent. By giving the AI less information, only the exact files and instructions required for its subtask, the execution remains hyper-focused and free of errors. As soon as the subagent finishes its specific workflow, it begins the handoff. The subagent returns a highly concise summary to the lead agent. It holds back the raw intermediate data, providing only the final result needed to complete the project. By combining parallel speed with these isolated memory bubbles, the system scales across massive projects while bypassing the threat of context rot entirely. From the user's perspective, the result of this loop is a polished, finished deliverable that arrived in a fraction of the traditional time. The lead agent has merged the sub-agent summaries, verified the cross-functional logic, and finalized the output. This changes your relationship with the technology. You are no longer micromanaging a chatbot or worrying about how much data you can fit into a single prompt. Because the system natively orchestrates parallel workflows and manages its own memory, the AI is now operating as a fully autonomous systems agency. The engineering is shifting from building smarter base models towards creating the systems that allow these models to manage themselves. Mastering AI now means learning how to delegate knowledge work to an entire virtual team, a shift that is currently redefining the nature of project management.